You're all welcome to this channel at Smithport Tutorial. Remember hashtag you don't need to be a scholar to get an A in maths. Now our topic is systems, mapping, and function. Now this is the part 2 of mapping and functions. Now let's do a quick review on what we talked about in the first section, in the first part. We talked about the meaning of the domain, the codomain, the range, and images of a set or sets, right? And we also talked about types of mapping, and I introduced to you the one-to-one mapping. Now, it is very, very important for you to be able to differentiate between the types of mapping. Remember, a one-to-one mapping, each element in the domain must have a unique element in the codomain. Now, let's go on to the second type of mapping, which is called the onto mapping. Now, the onto mapping states if every element of the codomain is an image of at least one element in the domain, then, this comma, then the mapping F is called an onto mapping. It means if every element in this codomain, in this example here in the codomain, is represented or is mapped to the element in the domain, then we can call that function a what? An onto mapping. So in this case, this is an onto mapping, but in the second case here, it is not an onto mapping because there is still an image which doesn't have a mapping here. So this is not an onto function because each element in the domain have not taken all the elements in the codomain. Do we understand that? A function is not regarded as a mapping if it is of this form. Let us remind ourselves, we have A and we have B, and let's assume we have C and we have D. Assuming A is mapped to C and also mapped to D, this is not a mapping. Is that okay? Because an element cannot be mapped or represented by two images. Is that okay? As a mapping is regarded as a correct function as a correct mapping if the image in the codomain, example this B, if this B is represented by two elements in the domain, then this is correct. But once one element in the domain is being mapped to two elements in the codomain, that is not a correct mapping. I hope you understand that. So an onto mapping, all elements in the codomain has at least or is being mapped to at least one element in the domain. Okay. Now let's look at some examples. This example states, let the range of the mapping K equals this. Now this is the range of the mapping. And remember, the range of the mapping can also be called the codomain. They are the images representing the elements in the domain. Now the function is what? States that x is a function of 2x minus 3. So our function is f of x equals what? Equals 2x minus 3. Now we're asked to determine the domain D of the mapping. Is that okay? Now the first thing to do is to just get your domain, is to get the elements in your domain. If these are our range, we just put the values into this formula. So putting the values, we have 2 into x minus 3. So for the minus 3 carries, x carries the value of minus 3. So in this case, if we take minus 3 here, we have 3 plus. Okay, let's solve it like a mathematician. Now we have f of minus 3 equals to 2x minus 3 equals to minus 3, right? Now this implies, not equal to, implies. Now minus 3 crossing over will give us what? Will give us 2x equals to what? Minus 3 plus 3. Now, so we have 2x equals minus 3 plus 3 will give us 0. If we divide both sides by 2, 2 cancels 2. Our x is equals to 0. So the first element in the domain is what? Is 0. Is that okay? Now let's solve the second one. Still using 2x minus 3. The second range, or rather the second image in the range, is minus 1. So we have minus 1 here. Taking minus 3 over, we have 2x equals 2 minus 3 plus 3. Now minus 1 plus 3 will give us plus 2. So we have 2x equals 2. We divide both sides by 2. By 2. 2 cancels 2. Our x is equals to 1. So our second element in the domain is 1. And I'm sure you can calculate the third one, which is 5. And we got that to be what? To be 4. Now, having that, let's clean our slide. Let's make our slide clean. Okay, now having that, let's represent this with our set. So we have the domain at the left hand side, which is our D, right? And we have the range of the codomain, which is our K. Is that okay? Now the range as given in the question is minus 3, minus 1, and 5. Now the domain we got after solving is 0, 1, and 4. Okay, now I'm drawing this for you to be able to tell whether it is a one-to-one mapping or an onto mapping. So 0, according to what we solved, is mapped to minus 3, 1 is mapped to minus 1, and 4 is mapped to 5. So from this mapping, or from this circle, we can see that each element in the codomain are represented or are an image of elements in the domain. So as far as all the elements in the codomain are being mapped to one or two elements in the domain, this is called an onto mapping. Actually, this is an onto mapping and this is a one-to-one mapping. We'll be looking at this at the end of this class. What do we call a one-to-one mapping and an onto mapping? We are going to be looking at the name at the end of this class. Okay, I'm sure you all understand this example. Let's move on to the second example. The second example says, let the mapping of x equals 2x plus 3, now this is a function, be mapped on the set of real numbers. Now these are the real numbers 1, minus 1, 7, and minus 5. Okay, these are the pre-images. So pre-images, they are the range, right? We are looking for the domain. Let's look at what this is saying. It says the pre-images are the elements of the domain which are positioned before the images in the codomain, blah, blah, blah. Let's solve this. Now, solving these, we have using 1, we have 2x plus 3 equals 1, right? So we have 2x equals 1 minus 3. So we have 2x equals 1 minus 3 will give us minus 2. Dividing both sides by 2. By 2, 2 cancels 2. X equals to minus 2 divided by 2 give us minus 1. So our first element in the domain using the pre-range of 1 is what? Is minus 1. When you solve the second one, that's using the pre-range of minus 1, you get minus 2, you get 2, and you get 4. So we get our domain to be minus 1, minus 2, 2, and 4. Now, having that, let's represent this diagrammatically. So the first oval is our domain. Second is our range. Let's see what our range is called. Okay, our range is called, it wasn't given here. So let's assume our range is called B. Our domain, let's assume the set of domain or the set of elements in the domain are called D. Now, our range first, we have 1, we have minus 1, we have 7, and we have minus 5. And for our domain, we have minus 1, we have minus 2, we have 2, and we have 4. So from our solving, we can see that minus 1 is mapped to 1, minus 2 is mapped to minus 1, 2 is mapped to 7, and 4 is mapped to minus 5. So this can be called an onto mapping because each element in the codomain are represented by are images of elements in the codomain. So this is an onto mapping, and this is also a one-to-one mapping because each element in the domain have a unique element in the codomain. Okay, now let's go to our third example. Okay, this third example is actually part is actually talking about the third type of mapping, which is the composite mapping. But I'm going to use it to illustrate to us a different type of onto mapping, which involves three sets. Now let's see. It says let F be a function between P and R, and G be a function between R and Q. So you have set P, R, and Q, and let them be two mappings such that the codomain of the function F is the domain of G. Now this means P is a domain, R is also a domain, or we can call it subdomain, while Q is our codomain. Is that okay? Now this is actually P is supposed, assuming it's two sets we are considering, P is supposed to be our domain, while R is supposed to be our codomain. But from this talk here, from this written instruction, we can see that the R, we're asked to make the R, which is the domain of Q, to be asked to make the codomain of R to be the general codomain of our P and R. Is that okay? Now, using this function, I will explain all of these next in the part 3 of mapping and functions, where we'll be talking about the composite mapping. But right now we have G is a function of f of a, right? What is f of a? F of a function of a, if we look at our diagram, is p. Is that okay? Function of a is p. The value of a is p. The element that is mapped to a is p, and that's why we have g of p here. And if you look at g of p will be giving us x. That's why we have x here. Do we understand? Okay. G of f of b from what we have here will be giving us r. Do we see that? It's giving us r, right? And g of r will be giving us still x. F of c, if we look at our diagram, will be giving us s, and g of s will be giving us y. Is that okay? Now f of d will be giving us q, and g of q will be giving us z. So I'll explain this better in our next in the part 3 of mapping and function. But right now, what we are generally considering is that all the elements in the codomain Q are being represented. They are all an image of the elements in the domain. Is that okay? So because of that, this is an onto mapping. Okay, this brings us to the end of all the examples under onto mapping. Now, the key point to note in these two types of mapping is that when a function is bijective if it is both one-to-one and onto. If the mapping is both one-to-one and onto, that function is referred to as what? As a bijective function, or a bijective mapping. An onto mapping is referred to as a surjective mapping. Is that okay? While a one-to-one function is called an injective function. Okay, thank you for watching, thank you for listening. Subscribe to this channel at Nickball Tutorial for more videos. Like and comment. Thank you very much, and we'll see you in our next class.